A large steel wheel is to be fitted onto a shaft of the same material. So कोई तो एक material है, steel दिया हुआ इधर. At 27 degrees Celsius, the outer diameter of the shaft is 8.7 centimeter. So this is a shaft. The outer diameter, this, is 8 centimeter at 27 degrees, 8.7 centimeter at 27 degrees Celsius. And the diameter of the central hole in the wheel is 8.69 centimeter. So this is the shaft, the blue colored one. A wheel has to be fitted on it. The diameter of the wheel, the inner diameter of the wheel itself is smaller than the outer diameter of the shaft. So the inner diameter is slightly smaller. Okay. So it's difficult to fit like this. Okay. So there are two methods to fit this wheel onto the shaft. So this has an inner diameter of 8.69 centimeter, whereas the outer diameter of the shaft itself is 8.7 centimeter. This is the wheel that has to be fit on the shaft. So either we expand the wheel by heating it, or we contract the shaft by cooling it. So there are two methods to do this. Now they have used the cooling method. The shaft is cooled using dry ice. At what temperature of the shaft does the wheel slip on the shaft? So this wheel has to be slipped on, it has to be fitted on the shaft. So what should be the temperature of the shaft? What should be the cold temperature of the shaft? We have to find that out, okay? The coefficient of thermal expansion is given here. So here thermal contraction is going to happen. Thermal contraction of the shaft. So at least the outer diameter should reduce from 8.7 to 8.69. Okay. So for that, the formula we use is delta L equals to L alpha delta T. This is the formula for thermal expansion or thermal contraction. So the change in the diameter is 0.01 centimeters. The initial diameter is 8.7 centimeter. Alpha is given to be 1.2, 10 to the power minus 5. And delta T, the change in temperature, the final temperature that we have to find out, the initial temperature is given to be 27 degrees Celsius. Okay. So the unit centimeters get cancelled out. So we do this 0.01 by 8.7 and 1.2. We have 10 raised to minus 5 in the denominator. So it goes in the numerator to become 10 raised to 5. This gives us T minus 27 degrees Celsius. So in calculating this, we get 95.785. So this is T minus 27 degrees Celsius. Rather, this is negative. Since we are using thermal contraction, the change in length is negative. The change in diameter is negative. Okay. So temperature is 27 degrees Celsius minus 95.785 degrees Celsius. So that gives us minus 68.785 degrees Celsius. So the shaft has to be cooled to this temperature in order to shrink it enough for the wheel to fit on it. So this is roughly minus 69 degrees Celsius. So that should be our answer. Okay.